Question 60 says, find the inverse of the following matrix. So first of all, let us find the determinant of this matrix. The determinant is secant times secant, secant squared of theta minus tangent times tangent, tangent squared of theta. So from pre-calculus, what do we know? We know we have a relation between secant squared and tangent squared. Secant squared is equal to 1 over cosine squared of theta. Remember that tangent squared of theta is equal to sine squared theta over cosine squared theta. Okay, so secant squared minus tangent squared of theta is equal to, so here you have 1 over cosine squared of theta minus sine squared theta divided by cosine squared of theta. The common denominator is cosine squared theta, and on the numerator you have 1 minus sine squared theta. But we know that sine squared of theta plus cosine squared of theta is equal to 1. The trig identity. Cosine squared is 1 minus sine squared. So this guy is nothing but cosine squared. So this is just 1. So as you can see, the determinant is 1 and it is non-zero. Let us go back to the formula that we introduced. A, B, C, D, a 2 by 2 matrix. As long as the determinant is not 0, we can find the inverse of this matrix, which is 1 over the determinant. We're going to switch the main diagonal entries, D, A, and then we're going to write the opposite of the rest of the entries. And this is just your inverse matrix. Let us do that. The inverse is equal to 1 over 1. And the matrix, we're going to switch secant and secant, which doesn't change the main entries. And then we're going to multiply both of these by negative sign or by the opposite. Negative tangent theta, negative tangent theta. So you can say that, hey, the inverse of this matrix is secant theta minus tangent theta, and secant theta.